Hello everyone, I'm Benjamin Juhl from TU Darmstadt. I'm also working as an administrator there for the HPC cluster in the context of this container NHR central project. I was investigating Podman and how usable it is for HPC systems, and I want to show you my results so that everyone who is also considering Podman for some reasons can save some work. So what is our initial position? Why did we choose to investigate Podman? Well, there was a clear reason. First, we had some users who had a need for Podman or Docker. For some specific reason, they could not work with Singularity. And so they said either Podman or Docker. And we did a quick investigation, comparison, and as basically all other centers, we had mostly security issues with Docker. And the promises of Podman, so that it is daemonless, you can run rootless containers, it uses user namespaces, so it's confined in them, and the configuration can be done in the user homes, all seem promising and would basically address the security concerns that we had about Docker. And we also saw that as we're using CentOS and we're in the transition to Red Hat now, Podman would be basically included with the operating system and an easy install and also easy to integrate into the cluster image that way. So the installation basically worked out of the box, so simply install it into your image. And as a root, there were absolutely no issues using Podman containers. So for management containers, this is a very, very good solution and very easy to implement for a Red Hat or CentOS system. However, the problem started when we wanted to make Podman available to users in the daemonless and rootless version. So I'll go quickly to the issues that arose and the solutions we had to some of them. So, of course, many of our new users want to use GPUs, and I guess the desire for containers also comes to some considerable parts from the AI community and the community who wants to use graphics cards. So to use GPUs, namely NVIDIA GPUs with Podman, you cannot use the, well, basic Podman, but you have to also include some packages from NVIDIA, which you can easily get from GitHub, and it's an repository there curated by NVIDIA, so officially has the seal of approval from NVIDIA, which is fine for us. And you also need to do some simple configurations in the image and some configuration file to allow the GPUs. And then users can pretty easily use GPUs. So that worked quite smoothly. The issues arose with namespaces, which is a nice feature to limit what the container can do. However, for this to work, you have to add or define the namespaces in the two files under etc, so sub-UID and sub-GID, and these have to be defined for each user there. And for local users, there is a feature, a package that allows you to automatically create these definitions when you add a new user. However, that's not really the case for our cluster users. So our cluster users come from an LDAP user management system, And I guess that's true for quite some other clusters, to use either LDAP or 389 directory system. And there's no easy way to create these entries in the configuration files when adding a new user to the LDAP user database. And it's also a bit cumbersome to always have these two files synchronized in the whole cluster. And you, of course, want them locally and not from a central source. And so that's a bit cumbersome. So the current solution is that the ability to use Podman is not automatically granted for all users, but users have to request use of Podman, and then their user namespaces are defined across the cluster, and then they can use Podman on the login nodes and also on all the compute nodes. So, of course, this has to be on all nodes that use Podman, and that's a bit cumbersome. If your container user base is small and not everyone wants to use Podman, you can still manage that, but it's definitely a drawback. The bigger drawback, however, are file systems. So I didn't find this information when I initially read about the Podman features, but found it later, and it was quite a cumbersome search once I encountered the error messages, because the error messages were not leading to the description of this problem, but it's in the Podman community apparently known and discussed, and it is documented. So rootless Podman will not work with any network file systems, or not work well with them, which means that you cannot store your container images on any NFS directory, and this also applies to GPFS and Lustre. It's possible, and I did this and showed users how to do it, and made a manual what they have to do to configure Podman to use local spaces, storage spaces, and then it works. However, our cluster does not have any local space that the users have permanent access to. So the user homes, their Scratch and group and project directories are all from network file systems. In our case, all from GPFS. And so they have no possibility to permanently save their Podman images. And this is, of course, a very considerable drawback. So every time they want to use a container, they have to build it from scratch. And of course, they can save it in a temporary directory. But this information will get lost with every reboot. And our login nodes and our compute nodes are rebooting in a regular fashion. And this lack of a central storage for the container image makes it also difficult to use the container over several nodes, as they cannot share the information for a container image from a file location that is accessible for all nodes, but they can only write the container to their local storage space, be that a memory or a local hard drive. And the other issue is that our compute nodes don't have hard drives anymore. So we are running a cluster without any hard drives, and the operating system is always in memory, which has quite some advantages, but no local storage also has some disadvantages, as we found out. And another more side problem more in the use of how to use Podman was in the use via the Slurm batch system, and I guess that is true for other batch systems as well. Is that when you are running a batch job via Slurm, this does not use the normal procedure of a login shell. So the directory run user ID does usually not exist. And Podman by default uses that directory for temporary files. So that's the run root, which can also be configured. And it is possible to configure it in a way that you can use it. For instance, you can, like the graph root, define it somewhere in dev shm, where you have space that you can access as a user. And this also means that there are some problematic environment variables like xdg runtime directory, which I listed here, which is also referenced by Podman and basically used before the run root from the configuration file is interpreted. So you have to unset some environment variables that might become problematic for other software that could also need these variables. But this is more of a minor problem and pretty much solved. There was also a quite annoying bug in some older versions, which is not a problem anymore now, as we have with the recent updates a version that can be used interactively. So in any Podman versions older than 3.1, if you had user IDs longer than 7 characters, and this for all our user IDs, so not for our local users and admin, of course, but for all our cluster users, you could not run Podman containers in an interactive mode, so you had to use the detached mode. And you could also not directly access the output, because this was not given in the detached mode, but you had to do a workaround over the Podman logs. Functionally, this was still working, but not having the ability to work interactively with the containers was, of course, also a big loss, and not what our users were expecting. So all in all, I would say Podman is probably not a system that is feasible for widespread and universal container use in HPC systems. Especially, and that's really the deal breaker, are the issues with the file systems, the network file systems. And according to the discussions I read in the Podman groups, it's not expected that these network file systems will anytime soon or ever be compatible with the namespaces. So these issues will probably persist. And at least for us, that's basically a deal breaker. We will, of course, continue to support Podman in its current form for the users that have based their current projects on them. But basically for all users who start, we would rather suggest that they use Singularity instead of Podman. So I hope this information can save time on other centers. And if you have any questions or suggestions, now is the time.
If I may begin, I mean, you went to great lengths to satisfy this user. What was the problem? Why he couldn't use Singularity?
He was experimenting on some scheduling methods with Kubernetes, and according to him, this could not be done with a Singularity, so he needed either Docker or Podman containers.
Okay. Another question I didn't get at the beginning. were you using Red Hat 7 or 8 equivalent?
Red Hat 8 equivalent.
Okay, thanks.